While I have a minute, I thought I would just make a quick video on biasing the Soldano SLO 30 head. So you have to pull the chassis to be able to get the new tubes in, and the new tubes are going to be replacement Sovtek 5881 WXT, which are robustly rated 5881s. Supposedly they can perform like 6L6s, but we are going to call it 25 watts maximum. And I've cheated a little bit and already took some measurements and got some values. So basically what's going to happen is the plate voltage is going to end up around 430 when I'm in the correct bias range. I do have an 8 ohm speaker load, a dummy load connected, impedance selector on 8 ohms. And I'm going to show you the biasing trick without probes, how to do it manually. So I've got my multimeter set for DC voltage and the small 200 millivolt range. And Soldano conveniently put R64 and R63 off of pin 8 of each power tube going to ground, coming off the cathode. So you can just use your meter to measure directly across that in this configuration, and it will tell you basically a 1-to-1 millivolt to milliamp conversion. It is a little off because these are not exactly 1 ohm resistors. They're actually around 1.3 ohms or 1.4 maybe. But it's going to get us in the ballpark, and it is actually going to protect you. It's going to be a little cooler than it says it is. I've already done some math here. The 25 watts expected from the 5881s, the voltage it's going to hit is right around 430, so that gives us 58 milliamps of current. Power divided by voltage equals current, if it was running 100% dissipation. Now, of course, we want to run somewhere in the 60 to 70% range. So I'm going to call 60% cool or low range, 65% right in the middle. We're going to call that safe or the medium range, and 70%, which is often done with EL34s and Marshalls and things like that. You know, that's like some mojo magic number. Not always true, but we're going to call that hot or the high end of the range. So we are targeting between 34 and 41 milliamps. Personally, I like to go in the safe range. Of course, if you go cool, your tubes will last longer and still sound good. You might get a little bit better tone out of going to the medium range, and you might get great tone but sacrifice your tube life. And these tubes are expensive, especially since they're Russian and all the tube drama that went down. The price has gone way up, and so I want these to last but still sound good. So I'm going to go for 37 to 38 milliamps is what I'm going to do. Okay, so like I said, R64 and R63 are the resistors we're going to measure across. VR12 or VR12, it says bias. This is the trimpot that we're going to adjust to get in the proper range. Again, I'm going to go for 37 to 38 milliamps. So I'll take it off standby, measure across the resistor, and you can see it says it's in the 28 milliamp range. It's jumping around a little bit because I'm not understeady. 28 and a half. Let's just measure the other one. And you want to be careful when you're probing in here. 28 again. Okay. So I'm going to, I have this plastic screwdriver just for safety. And I'm going to see if I can hold both probes with one hand while I adjust the trimpot. Maybe. Okay, turning clockwise, it is raising the dissipation, the current draw. So I'm very slowly and carefully turning this, just barely. It's jumping up. So let me get up to 37. I'll just go 38 because, like I said, I know that 1 ohm resistor is actually a little higher So this reading is probably, I mean, I don't know for sure, I'd have to do the math, but at least 1 milliamp low. Something like that. So 38. Let's just check the other one to be sure. 38. So this is a perfectly matched pair of tubes. So thank you, CE Distribution, for that. Also known as Antique Electronic Supply. All right, and I just want to show you one last thing, how to measure the plate voltage. So there's this ground lug up here in the corner. That's where I like to touch. You technically can touch any bare part of the chassis, possibly up in the bare part there, but we're gonna go there because I know that's a ground. And pin 3 on each power tube is the plate voltage, but there's a brown wire running to that one and a blue wire running to V6. It's right next to it, so you can actually touch that pad where the wire is. And like I said, there it is, 430 volts, 429. So on the money. So if you do these calculations, the 25 watts divided by the 430 gives you 58 milliamps at 100%. Then multiply by the percentage you want to figure out your current draw and set it for that. And that's what the 5881's. One last thing. Unfortunately, there's not enough room in this head shell to put 6L6 GCs. I believe the transformer could handle it and not really risk overheating or anything like that, too much current draw. But they don't fit. There's not enough room. It's almost like the exact height, and it would risk breaking the glass off of the base. So I had to go with the 5881s. So yeah, that's a little bit disappointing. I'm not sure if 6L6 regular ones, GBs, might fit, but I know the 5881 WXT fits, and that's what was in there when I got it. I'm assuming that's the factory tube, but one of the ones I had was totally bad. It was not conducting, and so that's why I got these and decided to make the video. So that's how you do a SLO 30. There is a chance to make another video where we actually show the crossover distortion on an oscilloscope and do it with signal and looking at the waveform as opposed to just doing this, kind of generic measurement. But this is going to be fine for you DIYers at home that don't use scopes and things like that. So yeah, somewhere in the 34 to 38 range on that measurement, you're going to be very safe. But check that plate voltage and be sure it's around the 430 mark and you'll be fine.